Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the lecture series of DAA, Design and Analysis of Algorithm. The topic that we are going to discuss today is about the divide and conquer strategy using Quicksort algorithm. So let's start the topic. So let us first see what is Quicksort algorithm is. So the working procedure of Quicksort is very simple. So this is also based upon the sorting mechanism. So as we all know, sorting is a way of arranging items in a systematic manner. Quicksort is the widely used sorting algorithm that makes n log n comparisons in average case for sorting an array of n elements. It is a faster and also a highly efficient sorting algorithm. This algorithm follows the divide and conquer strategy. So what is divide and conquer strategy? So in divide and conquer strategy, we all know the larger instance of a problem will be subdivided into several sub-modular tasks or sub-problems, and then using the conquer step, these sub-problems will be solved systematically, and finally the combine step will combine the elements of all the sub-problems, and then it will give a solution for the larger sub-problem. So this is about the divide and conquer strategy. So let's see how this divide and conquer strategy works for Quicksort algorithm. So the first step in divide and conquer is divide step. In this divide step, it first picks a pivotal element, that is the partitioning element. So the pivot element will be first picked up. After that, partition or rearrange the array into two sub-arrays. So such that each element in the sub-array is less than or equal to the pivot element, and each element in the right sub-array is larger than the pivot element as given in the diagram. The next step is the conquer method. So in the conquer method, we are going to sort recursively two subarrays. We are going to sort the two subarrays recursively until our final output is received. The last step of divide and conquer strategy is combine. So here you have to combine the already sorted array. So let's see in detail. Quicksort. Quicksort is an element. Picks an element as a pivot, and then it partitions the given array around the picked pivot element. In Quicksort, a large array is divided into two sub-arrays in which one holds values that are smaller than the specified value, that is the pivoted value, and the another array holds that value that are greater than the pivoted element. After that, left and right subarrays are also partitioned using the same approach. It will continue until the single element remains in the subarray. So this is how a Quicksort algorithm works. So let's see. The first step will be selecting a pivot or the partitioning element. Here the first element is the partitioning element. Rearrange the list so that all elements in the first S positions are smaller than or equal to the pivot, and all the elements in the remaining n-1 positions are larger than or equal to the pivot. So we'll see that how it works in an algorithmic way. Then the next step would be exchange the pivot with the last element in the first subarray. The pivot is now in its final position. Finally, sort the two subarrays recursively. So here is an algorithm for Quicksort algorithm. So first we'll decide how to choose a pivot element. Picking a good pivot or the partitioning element is necessary for the fast implementation of Quicksort. However, it is typical to determine a good pivot. Some of the ways of the choosing pivot are as follows. Pivot can be a random, that is, select the random primate from the given array. You can randomly choose any element from the given array of elements. The next one, pivot can be either be the rightmost element or be the leftmost element of the given array. The third one would be select median as a pivot element. So there are three ways to choose a pivot element. One is being to select a random element. The next one being choosing a left value or the right value as a pivot element, or you can choose the middle value as the pivot element. Now let's see the algorithm. So this is the Quicksort algorithm given. So here the partition algorithm rearranges the subarrays in a place. So let's see how does it work. Now let us consider the Quicksort algorithm. To understand the working of Quicksort algorithm, let us take an unsorted array. So we can have any element as a pivot element, and then we have to choose in the left side of the pivot element it should be the values which is lesser than the pivot element, and on the right side it should be the value of the pivot element should be lesser than the rightmost value. So this is how the Quicksort algorithm works. So we can consider any pivot element. So let's see the algorithm in detail. So partition with an array element will be the algorithm. So the input will be the array of n elements, output also will be the spec position written as this function value. So let's see an example. So the next one we will discuss about the time complexity of the Quicksort algorithm. The best case complexity in Quicksort algorithm is that it occurs when the pivot element is the middle element or near to the middle element. The best case complexity of Quicksort algorithm would be order of n log n comparisons. Average case complexity would be it occurs when the array element are in jumbled order, that is not properly ascending and not properly descending too. The average case complexity of Quicksort, that is random arrays, is big theta of n log n comparisons or big O of n log n comparisons. Worst case complexity in Quicksort, worst case occurs when the pivot element is either the greatest element or the smallest element. Suppose if the pivot element is always the last element of the array, the worst case would occur when the given array is sorted already in ascending or descending order. The worst case time complexity of Quicksort algorithm is big O of n square or theta